All right, guys, day 9, linear inequalities and systems. So remember, an inequality has a less than, greater than, less than or equal to, or greater than or equal to. Common words for less than, right? Smaller than, any one of those things. But when you start getting into greater than or equal to and less than or equal to, so let's say y is greater than or equal to 3x plus 2. When I write something like this, um, we could also say something like y is 3x plus 2 is at most whatever y is. So whenever you think of the words at most, I want you to think of money. Would you rather have at most this amount or at least this amount? So at most means there's a cap. You can't go above that amount. Okay. And then when we do at least, we want to think about, oh, that means I can have that, or I can have that much or more. So it's my amount is going to be greater than or equal to this, or less than or equal to that. So think about that when you guys are reading into this. So the first one, we want to graph each solution for any inequality. So we're going to treat it just like a line, right? We know the slope is equal to -4 over 1. So we're going to go down 4 and right 1, or up 4 and left 1, and b is equal to -3. So I'm going to graph my points. So -3. I can't go down 4, so I'm going to go up 4, 2, 3, 4, and then left 1. I can do up 4, left 1 again, and that's going to be my line. Now this is an equal to line, has an equals in it, so that means it's going to be a solid line, okay? The dotted line is when it's strictly greater than or less than, and that indicates that the points on the line are not in the solution set. So here these points are in the solution set, so we got our line. This is the boundary line. So y is less than or equal to -4x minus 3. And because it's greater than or equal to, we're going to shade all the y values that are or it's less than or equal to, less than points to the left side. We're going to shade all the y values that are less than the line. All the less than the line are down here, so we're shading in this direction. Okay? And then we're going to place an S on the graph to indicate the solution space. All right? For number 48, we want to solve. So we can move the y to the other side and move the 1 back, okay, here. And we're going to get that should be 1. We're going to get the graph y is less than, actually, we're not going to get that. We're going to get 2x minus 1. So you can do this in kind of steps here. If you want to just do the y first, right, we're essentially going to get 2x is less than y plus 1, and then move the 1 back. So 2x minus 1 is less than y. And remember, we actually want to write the y first. So we want to put the y in front. We flip the inequality around, and we do 2x minus 1. So the slope is 2. The y-intercept is -1. So boom, positive 2 means up 2, right 1, up 2, right 1, or down 2, left 1. I graph my line. All right. And remember, this is a dotted line, okay? So what I can do is, if I have an eraser, I can go back and I can erase part of it. Here, I'm just gonna, color white over some of the line to indicate that it's dotted here. So I got a dotted line. Or if you forget and you do it in pen for some reason, because it's a Regents exam, you can always just do a quick indication here that this is supposed to be a dotted line. And that is also going to be okay to do. So if you forget, you can just do that. Greater than 2x minus 1. And we're shading up because it's greater than, so we're shading in this direction. And then we put our s in the solution set. All right, same thing here. So we're going to subtract the x. So we're going to get y is greater than, 3y is greater than -x plus 3. We'll divide everything by 3. And we'll get y is greater than, and we're going to end up getting a -1/3 x plus 1. All right, so the slope is -1/3, the y-intercept is +1. So I'm going to go ahead and graph +1. Slope -1/3, down 1, right 3, or up 1 and left 3. There's my line. All right, so y greater than negative 1/3 x plus 1. And then greater than, we're going to shade up. And once again, I forgot this is supposed to be a dotted line, right? So dotted. Okay? Or if you're using a pencil, just go back and erase parts of the line there. All right, which graph represents the solutions? So remember, we can use a calculator for this, okay? We want to pull up a calculator. There it is. So we're going to go to on, new document. No, I don't want to save. Give me a graph. All right, we can delete this and we can pick our inequality here, okay? So we want to, for our graph, we want to do y is less than or equal to x plus 3. So we're going to choose less than or equal to, and then x plus 3. There's our first line, okay? And then we're going to do the same thing with the second one. It's y is greater than or equal to negative 2x plus 2. So we tab it, y. Remember, you can do control equals as well. Greater than or equal to, and we said 2x plus 2, I believe, minus 2. And it looks like it's negative. Man, I was wrong on all fronts. Negative 2x minus 2. All right. And then enter. There's the second one. And so we're just going to match the graph that looks like this. So we should be shading all the stuff over here on the right. So this is out, that's out, this looks good, that looks bad. So we know that it's this choice right there. All right, to graph a system, graph each separately. Okay, you can choose a test point or you can just shade accordingly. You can use zigzag stripes, you can use different colors if you want to bring colored pencils with you or different colored pens. And then just put an S where the both shadings overlap. So 297, they're coming because we're on fire over here. All right, online electronics store must sell at least 2,000. All right, just waited till we got rid of that lovely sign. So the store must sell at least, ooh, there's our at least, $2,500. So we know that the amount is going to be $2,500. Now, we want to sell at least that amount. So that means we have to have that much or more. So we want to be greater than or equal to be at least, okay? And we have printers and computers, okay? So the cost, each printer costs $50 and each computer costs $500. The store can ship a maximum of 150 items per day. And I want to, so here I'm going to need a key. I need to know, and if you think about it, the graph is already giving me a key. The number of computers is my y-axis and the number of printers is my x-axis. So I already know, okay, that it's the printers cost 50, so it's 50x plus 500y. And then I also know that there's a maximum of 15 items per day. So the second inequality is x is less than or equal to, right? Or 15 is, in this case, this symbol is greater than or equal to, okay? The number, and it's just x plus y. We add them together here, and that amount has to be essentially less than that. So first thing we need to do is we need to figure out how to graph these things. So if you take a look at, and we can actually kind of, I'm going to make this a little bit smaller here so our purposes. All right, I'm going to take the first equation. So it's 15 greater than or equal to x plus y. Okay, we're going to move the x to the other side to solve for y so we can graph this thing. And I get 15 minus x, or remember what we said, put the x first, mx plus b. So negative x plus 15 is greater than or equal to y, and we're going to flip it around now. So y is less than or equal to, remember it's eating the bigger number, negative x plus 15. That's the first graph, okay? Second one is 2,500 is less than or equal to 50x plus 500y. So we'll solve for y again. So let's subtract the 50x minus 50x. And then we're going to get negative 50x plus 2,500 is equal to 500y. We'll divide by that 500. And we'll have our answer. So 10 times. So this is essentially negative 110. So this is negative 1 over 10x plus And then 2,500 divided by 500 is 5. All right. And this should be greater than or equal to here. And so we're going to want to flip this around. So we get y. It's eating the y value. So negative 1/10 x plus 5. And then we're good to go. So now I know I can graph these. So I need to go up to at least 15 because that's my y-intercept. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. So I can count by ones. It'll be okay to count by ones here. So we're going to go up. The first one, y-intercept is 15. We'll do that one in blue here. So like we said, we just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then I put a dot there, and my slope is negative 1, so it just goes down 1 and over 1. All right, down 1 and over 1, and that's what my line is going to look like. So, all right, and it's going to extend just right along there. Two, three, four, five, six. And this should all should be 15 because most I can do is 15. So if x is 0, y is 15. If y is 0, x is 15. So keep that in mind. So there's the first line. The second line, we have a y-intercept of 5. So I just go up, and I'm going to make this bigger for our purposes for this guy. All right, I got a y-intercept of 5. So 1, 2, 3, need some red. 4, 5. And then it's 1/10. So I go up 1 over 10. 1, 2, 3. And it's negative, right? Negative 1/10. So I go down 1 over 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pow. Down 1 over 10. 1, 2, 3, 5, 6, 7, 8, 9, 10. We can fit it. Okay? So there we go. So that line is going to look like this. All right? Whoa, that's a big line. All right? I went down too far there. There we go. All right. And so there's my two graphs. We want to make sure we kind of label each line since there's two lines on there. So this is going to be the line y is greater than or equal to, sorry. We got our two equations. So let's go back to the small view. Less than or equal to negative x plus 15. So we have less than or equal to negative x plus 15. All right, and so we know we're going to shade in this direction down here. All right, and we also have y is greater than or equal to negative 1/5 x plus 5, so we're going to shade up here. And so we can see our solution set is anything that occurs right in there. All right, we'll do this in a little different color so you can see it. Anything that occurs in there. All right, and we also want to label the other line. So this is y is greater than or equal to negative 1/10 x plus 5. All right, and then determine a combination of printers that would allow electronic sorting to meet all of its constraints. So you could have any one of these numbers in here, just pick one, okay? So I could go up 2 and over 1, 2, 3, 4, 5, 6, right? Up 2 and over 6, right, is at doesn't go above 15, and it still satisfies above that amount. So you could just say I picked a point that's inside the solution set, and that would be your answer, okay? On the next guy, graph and inequality shown below. Write one that represents the graph. So remember, we want to pick the y-intercept. So we can see the y-intercept here is right there, which is negative 3. Okay, and we can see the slope by just picking another nice point, which is like right here. And we can actually count the rise and the run. So I have to go up and then right. So I'm going up, that's positive 4, and over 2 to the right, positive 2. So my slope is 4 over 2, which is 2. My y-intercept is negative 3. And so the inequality, because I'm shading greater than and it's solid, is going to be y is greater than or equal to, and then it's 2x minus 3. Okay? You also could have picked this point instead of that point and just seen that you go up 1 over 2. Just pick one that you know is on the nice end of the box there, so it's a nice number. It's not going to be a decimal. And then on the same sets, graph the inequality x plus 2y is less than 4. So x plus 2y is less than 4. We're going to move the x over first. So 2y is less than negative x plus 4, and then we'll divide everything by 2. So y is less than negative 1/2 x plus 2. So we go ahead and graph 2. All right, I'm just going to get rid of the slope here, just for graphing purposes. All right, so we're going to go ahead and graph 2 on the y-axis. And then we have a slope of negative 1/2, so down 1, right 2, down 1, right 2, down 1, right 2, up 1, left 2. And you can even fill out the whole graph here with points. And then we're just going to draw a straight line in here, guys. So if we want to stay consistent with colors, all right. So there's our line. We're throwing arrowheads on the end. We labeled it. Y is greater than or equal to, right? Negative 1/2 x plus 2. This was y is greater than or equal to 2x minus 3. And then Oscar thinks the point 2,1 is in the solution set. Point 2,1 is right here. Keep in mind, our line should be dotted, right? So this should be dotted. And it's less than, so we should be chaining down. So if it's on the dotted line, right? If the point is on the dotted line, the point 2,1, the answer is no, okay? So is Oscar right? I do not agree with Oscar. No. Oscar, you're wrong, okay? And then you can just explain that the point is on the dotted line and not in the solution set. All right, so that will help us answer Oscar's incredible question. And we also want to throw a beautiful looking S inside our solution set there. All right, quadratic linear systems and other lovely systems of polynomials, okay? Remember, when you're solving algebraically, we're just going to get set them equal to, solve both for y, set them equal to each other, and since it's a quadratic, get everything on one side in standard form, keep the x squared positive, and then see if you can factor, and if not, you're going to do completing the square quadratic formula. It's up to you. So this one wants me to come up with the equation g of x is equal to 2 times k of x. All right. So g of x is 2x squared plus 3x plus 10, and we're going to go full screen here. So, all right. Whoa, where'd that come from? Get back to it. All right. So plus 10 is equal to 2 times k of x, which is 2x plus 16. All right, so we got to distribute, combine like terms if we can. 2x squared plus 3x. No like terms over here, so that stays as is, okay? And this is equal to 4x plus 32. And then we're just going to move everything on one side. So we're going to move the 4x over. We're going to move the 32 over. And I get 2x squared minus x minus 22 is equal to 0. I don't know if this is going to factor. So 2 times negative 22 is negative 44. I need this to add or subtract to give me negative 1. So if we go through it, right, 1 and 44, 2 and 22, 4 and 11, 5 doesn't work, 6 is not going to work, 7 doesn't work, 8 doesn't work, so we're kind of stuck. It's not going to factor. So what do? Another thing you can do to check to see if it factors is if you just do a quick graph, okay? So let's open a graph page, and we can type in 2x squared minus, get rid of that, so minus x minus 22. All right, see where this hits, where the roots are. So if you get nice numbers, it might actually factor, okay? I can check the 0, and look at it, it's negative 3.08. Like, no, this is not going to be nice, okay? So we're going to have to choose a method of solution here. So since there's a 2 in front, I don't want to do completing the square, so I'm going to choose quadratic formula, okay? So x is equal to negative b plus or minus, remember this is on the formula sheet, so you don't have to remember it, b squared minus 4ac, the square root of all that, divided by 2a. So a is 2, b is negative 1, and then c is negative 22. So x equals negative of negative 1, or 1, plus or minus negative 1 squared. Notice we're using the parentheses there so we don't get the wrong answer. Squaring that negative, so it'll always come out positive. 4 times 2 times negative 22, okay? Over 2 times 1, which is 2. All right, we went nearest 10th. So what I'm going to do is plug in everything inside the square root symbol. Don't actually type the square root in there, guys. So it's just, give me a new page, give me a calculator page, okay? So it's negative 1 squared minus 4, right, times 1 times negative 22, all right? And if you want to throw all those lovely parentheses in there, you do it, all right? And we get 89, okay? So that's the number in the radical. So this turns into 1 plus or minus the square root of 89 over 4. And now we're going to pull up our two separate solutions. So the first solution is x is equal to 1 plus the square root of 89 over 4, which equals, and then I'm going to drop that in, 1 plus the square root of 89. I'm going to hit parentheses here. Control divide, because I want to get that fraction bar, over 4. And I get 2.6085, okay? 2.6085. Or we're going to do the minus, right? X is equal to 1 minus the square root of 89, okay? And you know what? I just realized we did this wrong. Hopefully you caught it and was like, what is he doing? This should be a 2. So this is actually 177. So small change, okay? This is where you, well, I'm going to assume you're using pen here, so like me, all right? So we just want to, that's not what we wanted. We did not want that, people. We're going to just drop this in the square root of 177. And then let's see. So we'll go back. We're going to grab this guy. We're going to go up and delete 177. And we get 3.57603. Nearest 10th would be 3.6. Okay. And then I grab this. I go back. Minus. And it's negative 3.1. Okay. So our solutions, there's our set. 3.6 comma negative 3.1. There's our answer. Make sure there's an or in here because you should have one of the answer or the other one. All right. Which pair of solutions have negative 1, 2 as a solution? So, guys, like we talked about before, just take your calculator, okay? We'll do new document. Don't want to save. There's my graph. The first one is x plus 3. The second one is y is equal to 2 to the x. Okay, so tab first, and then 2 to the x. And you guys can just go check your table if you want. I know I'm looking for the point -1, 2. I go to -1. They're both not 2. One's 2, the other one's 0.5, so that one's out. Okay? So then I'm going to go to the same thing here. So we can just do Control-T to get out of this. I can press Tab, and I can actually go up and I can edit these functions, okay, and get rid of graphs. All right, so this should be x minus 1, and this is 2x, and you can see that's definitely not, oh, that's definitely not -1, 2, so that doesn't work. And then you can go keep checking. So we can do it that way. We can also plug our point in and see if it works. So if we put -1 in for x, right, in this graph, this is going to be 4 times -1 plus 6, which is -4 plus 6, okay? And this does indeed equal 2, okay? So that works. And if we plug -1 in for x squared here, so -1 squared minus 3 times -1 minus 2, this is going to be 1 plus 3 minus 2, and this does indeed, 4 minus 2 is 2. So this will also get you the answer by plugging that point in. There's just another way to do it. And then based on the graph, the equations f of x and g of x, right, the solutions. When you do f of x, so when you evaluate f of x, this is the same as saying y, okay? So if f of x is equal to g of x, okay, that means that at that x value you're picking, okay, whatever the x values you're picking, they have the same y value. So the solutions to the equation, okay, are the y values, okay, of the points of intersection. That's what we're looking at when we say f of x and g of x. They have the same, when you check the x, they have the same y value. All right, and nothing on the back, guys. So that's it for today. Have a great day. We'll see you guys later.